All right, so matrix equations are a lot like any other equations. You might skim through this worksheet that we're going to work on and notice that there's some equations that are set up similar to this. It might say something like you have a matrix plus A that you're looking for, and that equals another matrix. And if you were trying to solve that, you would subtract this one from both sides, right? Because if you subtract a matrix from itself, these will cancel out, and then you would be left with whatever matrix A was. So those are simple. So I want to actually walk through a few that are a little different. So I'm going to start with question 1 here. In this question, I see I have a matrix, and it is being multiplied by some matrix X to give me another matrix. So normally if we have something multiplied by something else, we would divide that. The problem is we do not have an operation called division by matrices. So since we can't divide, our option is to multiply by the inverse. So we're going to start this question by we need to figure out what the inverse of this matrix is that is with the X component. So remember, when we find inverse, we're going to start with the determinant. So my determinant is going to be 4 minus 0, so that's going to be 4. And when I do the inverse, I do 1 over the determinant, so 1 over 4 times, remember I'm going to swap the first diagonal, so that becomes 4 and 1, and then change the signs in the other one, 1 and 0. I am going to go ahead and multiply this out just like we were doing yesterday, so this is going to become 1, 0, 1/4, and 1/4. All right, so now what I can do is multiply both sides of my equation by this inverse. So that's going to give me 1, 0, 1/4, and 1/4 on the left side. And then I'm going to do the same thing on the right side. 1, 0, 1/4, and 1/4. On the left, we learned in our lesson that when we multiply inverses together, we are left with the identity matrix. So on the left side, this is going to give me 1, 0, 0, 1, and I know that without even having to work it out, times the matrix X equals, on the right side, I notice this is a 2 by 1 and a 2 by 2. If you remember, we can't multiply that way, so I'm actually going to need to move this, like switch the order of these, so this is going to become 7 and negative 11 over here. Now I can multiply those, because now my inside dimensions match. I'm going to be left with a 2 by 1. Alright, so that's going to give me this. Remember, we're going to do row times column, so that's 1 times 7 plus 0 times negative 11, so that's going to be plus 0. And then 7/4, 1/4, so now I move to the second row, down here, second row times 7, and then 1/4 times negative 11, minus 11/4. And when I simplify these out, that's going to give me 7 on the top row and negative 4/4 on the bottom row, or the same as negative 1. All right, so now my equation says this, and I'm just rewriting this so that you all can kind of see a little bit better what I have. This says 1, 0, 0, 1 times the matrix X that I'm looking for equals 7, negative 1. And remember, when we multiply a matrix by its the identity matrix, we get the matrix itself. So that means that in this instance, X actually equals the matrix 7, negative 1. So this is our solution to our equation. And one thing I would encourage you to do is use your calculator or use that online matrix calculator that we're going to have for EOC to plug this back into the original equation and see if it does, in fact, actually work. So if I have this is my X, I can use my original equation and multiply those together to see if I get the right side. Okay, and so before I move on, just some encouragement that not all matrix equations are this complex. Not that this one is too bad, but some of them are, as I referred to earlier, as simple as just subtracting something from both sides. Or maybe even as simple as, let me see if I can find one, maybe even as simple as dividing by a scalar factor. All right, so let's look at one more together. All right, so here's question 6. And I notice in this question I have a matrix, and I am multiplying by z, subtracting another matrix, and that gives me a final matrix. So I'm writing this out just for a second so you can kind of see what our game plan is going to be. I noticed the first thing I might need to do is get rid of this one that's being subtracted, so I'm probably going to add it to both sides. And then I would likely need to, we can't divide here, so instead of dividing, I will end up needing to multiply by the inverse. Multiply by the inverse. So I'm going to go ahead and roll with that game plan. So I'm going to start by adding this matrix to both sides, negative 6, 4, 0, 1, and 1, oh, sorry, I don't know why I said that. I have to add the same matrix to both sides, 0, 1. Notice on the right side, or sorry, on the left side, these two are going to end up canceling out. I'll get the 0 matrix, which means I don't even have to necessarily leave it there. And then on this right side, mercy, I'm struggling with directions, negative 5, negative 4, negative 20, and negative 16. All right, so let me copy down this other part of the problem. I have 0, negative 1, 0, negative 4, and that's multiplied by z. Okay, so now I know I need to be finding the inverse, so I'm going to go ahead and do that. So I will start by finding the determinant here. So my determinant is going to be 0 minus 0 again, which is actually a 0. So remember from yesterday, if the determinant is 0, there is no inverse. And because there is no inverse, I'm not going to be able to isolate this z, which means in this case there is actually no solution for the matrix z. So for this problem, you would obviously need to show that there is no inverse, but then you would just say that there is basically no solution here. There is one other question on this worksheet that gives no solution for this same reason, because there's no inverse, but all the others should have a solution. All right, so this is your video for today, and you are finishing the other 8 problems on this worksheet.